This is RD Sharma Solution Class 12 Chapter 19. We are taking the exercise 19.2 Indefinite Integrals. Now all these questions which you see here, these are very basic questions and they will employ the basic formula of integration or basic results of integration. Now this question which you see here, 3 into x under root x plus 4 under root x plus 5. So when we have to integrate it, the other terms means the terms will be dealt separately. In order to get this x under root x, that simply means x into x to the power half. Under root x is nothing but x to the power half. And when the base is same, the exponents get added. We need to add 1 and half. So we have x to the power 1 plus 1 by 2. And 1 plus 1 by 2 is simply 3 by 2. So that's how you get x raised 3 by 2. How about under root x? As I just suggested, under root x is nothing but x to the power half, x raised half. So what do you get here? 3 into x under root x, as we just discussed, it's x raised 3 by 2, plus 4 under root x is x raised to the power half, and 5 is there already. And all will have dx because we are integrating with respect to dx. So whenever we are integrating, say a plus b or a minus b dx, the terms will be integrated separately, or it can be integrated separately. So we have 3 terms here, 1, 2, 3. And as we know, the differentiation of constant is if it contains any variable, then the constant comes in front. It will not be differentiated. For example, here 3x raised 3 by 2, I am separating these 3 terms. Integration of 4x raised half. Now we have this 5, and everywhere there is a dx. Please remember, I am not writing the dx, but you need to keep in mind that dx will always be there. These constant time I was talking about, it can be taken in front. That is 3 I have taken outside, so x raised 3 by 2. Dx I am not writing again. This is our you and me. We have already discussed that dx you are going to write because we have to do so many questions. So I am just refraining from writing dx most of the time. Okay. The main thing is 5 here. Nothing is there, that means x raised 0. X raised 0 simply means it's 1. Anything to the power or any variable or any constant to the power 0 is 1. So basic integration formula is x raised and dx will be simply x raised n plus 1 divided by n plus 1 and along with the constant of c. So this constant of c, constant of c, constant of c, there will be 3 constant of c and we will combine them to form a simple combined constant of c. Now this is x raised n plus 1 by n plus 1. I am applying it here. Here also x raised half plus 1 divided by half plus 1. So don't need to put this integration sign because already the integration of x raised half is this one. Again here also x raised 0 plus 1 by 0 plus 1. When we integrated this, we got constant of integration. Here also constant of integration. Here also constant of integration. So this constant of integration, constant of integration, constant of integration, just call them C1, C2, C3. It can be any constant of integration. They combine to form a simple constant of integration, which you can call it as constant C. Because every term will give you a constant. And those constant we have combined it to a constant because actually it's a constant. So we don't know the value, so we can just put it as C. Now what is 3 by 2 plus 1? It's 5 by 2. I'm showing it to you here. It will be x raised 5 by 2. In denominator also we have 5 by 2, but this when it goes up, it will invert. The reciprocal of this will be multiplied. Here also 4, half plus 1 is 3 by 2 and this is x 2 by 3 goes up, so I'm just replacing it or ignoring it right now. X raised 3 by 2 plus here x raised 1 divided by 1, so let us write it as x only. Combine all these c and call it as c, capital C. We get 6 by 5 x raised 5 by 2 plus 4 to the 8 by 3 x raised 3 by 2 or x to the power 3 by 2 is the same thing, which I will generally use interchangeably. X raised 3 by 2, this x, see 5 was already there. So we have taken this 5 as constant and integration of dx is simple x. So 5x you get and then we have a constant c, capital C. This is the final result what you get. Now this is the final result in front of you. All of them has to be dealt separately and the formula wherever it is possible is to be written. So wherever you write, do the rough work so that examiner knows what you're doing. Next one, before we go ahead, there are certain results of integration. integration of a raised x, a to the power x, is simply a raised x divided by log a. You can write it as a raised x and log base is e. When the log has base e, we write it as ln. ln. How about 1 by x? We'll get 1 by x also. Integration of 1 by x is simply ln x or log base ex. I'm not writing dx, please remember. If I forget to write dx, that simply means you have to write dx. Dx will always be there. Every time it will be there. So 1 by x integration will be ln x. Log base ex is ln x. Now this will do normally because it's the most standard result of integration. So we have this 2 raised x dx, and then we have 5 by x dx. So the first step is to separate all these terms and then deal with them one by one. We have 1 by x raised 1 by 3 dx. So this 2 raised x is a simply integration of a raised x. It will be a raised x log a, and since log is base e, I'm writing ln 2. What is 1 by x dx? We just discussed it. It's ln x. So we have ln x here, 5 into ln x. Now this x raised 1 by 3 in the denominator will go up, and it will be x raised minus 1 by 3. When we have x raised minus 1 by 3, it's x raised n integration. So it will be x raised n plus 1 by n plus 1. Now I'm not adding the constant. It will be there everywhere. So x raised minus 1 by 3 plus 1 by minus 1 by 3 is the integration which we are doing. 1 minus 1 by 3 is simply, so it's 3 minus 1 by 3, it's 2 by 3. So x 2 by 3 divided by 2 by 3. And this denominator 2 by 3, as I told you, when it goes up, it will be inverted. Reciprocal will be taken. So 3 by 2 into x raised 2 by 3. So there are 3 different terms we got, and finally we have the constant of integration that needs to be added. So this is your final result which we get here. So the standard result are being used here, and this is for you that you understand the formula, and when you do the practice, the formulas will be on your fingertips. Next is under root x. This is under root x is simply x raised to the power half. So x to the power half is under root x. Now let us resolve this first. Then we'll resolve, and then we will deal with the integration. So the first term is x raised half. Inside this we have ax square plus bx plus c. Now multiply x raised half with each of the terms. So a into x square into x raised half. This will be the first one. So the power will get added of x raised to the power 2 and 1 by 2. 2 plus 1 by 2 is simply, this is 2 to the 4, 4 plus 1 by 2, 5 by 2. So x to the power 5 by 2 it will be. A into x to the power 5 by 2 plus b here x raised half, and this x to the power 1. 1 plus half is 3 by 2. So we have b into x to the power 3 by 2. 3 by 2. And then we have this c multiplied by x raised half will be c into x raised half. So this multiplication, this is the final, you can say, expression which needs to be integrated. Now I'm separating these terms. Integration of a x raised 5 by 2 dx, integration of b into x raised 3 by 2, and then we have c. Remember, dx will always be there everywhere. C x raised half, integration of this one. So this constant will take outside. Integration of x raised n will be x raised n plus 1 by n plus 1, or x to the power n plus 1 by n plus 1. Please remember, the denominator will go up if it is in the p by q form. It will be q by p when it goes to the numerator. Now x raised 5 by 2, as I am saying, dx will always be there. So we have a mutual agreement. I am not writing dx, and you will write always dx. Next one, b integration of x 3 by 2. This step is only I am taking the constant outside, because the constant in the differentiation or integration will not affect. It can be taken outside. What is x raised 5 by 2 plus 1? 5 by 2 plus 1 is 7 by 2. So x to the power 7 by 2 divided by 7 by 2. When it is in the denominator 7 by 2, it goes up. It will be 2 by 7. This one. So 2a by 7 plus b. X raised 3 by 2. 3 by 2 plus 1, that is 3 plus 2 by 2. So x to the power 5 by 2 in the denominator we have 5 by 2. So we have 5 by 2 in the denominator, and this goes up 2 by 5 it will be. Now this one, x to the power half plus 1 is x 3 by 2. So we have just done 3 by 2. 3 by 2 in the denominator, it goes up, it will be 2 by 3. So what will be the final term? 2a by 7 x to the power 7 by 2 plus 2b by 5 x to the power 5 by 2. And then we have plus twice of c by 3x to the power 3 by 2. So these are three terms. Let me write the third term also. It will be 2c by 3 x to the power 3 by 2. And what is remaining? A constant of integration. This is your final result. So what I explained you is in front of you. That is how you are going to write neatly, cleanly, and explain it to your examiner. So whenever we have these kind of terms, there is no other way but to multiply them. So let us multiply these two. You can take any of the two terms, multiply, and then multiply with the third term. I am taking the last two of them, 3 plus 2x and 1 minus 2x. Let us multiply them. When we multiply, you get 3 into 1, then 3 into minus 2x, then 2x into 1 and 2x into minus 2x. So this is the term you are going to get. You can combine these two. Minus 4x square you can bring in front. It's not necessary, just for the sake of default or traditional customs we have followed, that we always start with the highest power. This term has to be multiplied by 2 minus 3x now. So 2 into negative 4x square, 2 into negative 4x, and 2 into 3. These are the three terms you will get. So you will get negative 8x square, and 2 into minus 4x is minus 8x, 2 into 3 is 6. Now minus 3x into minus 4x square, minus 3x into minus 4x, and minus 3 into 3. These will be the other three terms you will get. So this is 12x square, and finally minus 3x into 3 is minus 9x. Okay, let us combine those which have the same exponent. That is the similar term we call them. We have this first term as 12x cube because there is no other x cubes here. So 12x cube will be the first term. What will be the second term? It will be 12x square minus 8x square. That results in 4x square. So 12x cube, and this one 12x square minus 8x square is 4x square. Now negative 9x, negative 8x, 9 plus 8 or minus 9 minus 8 will be negative 17x. Then we have plus x. So this after multiplication, which I showed you on the right side, I am writing it on the left hand side, the final term after multiplication. So 12x cube plus 4x square minus 17x plus 6 into dx. Now when we differentiate it, this will be taken separately, one by one, and constant will come in front because it will not affect the integration of the variable. So that's how I am doing, separating the term and keeping the constant outside. And this always remember there is a dx because the integration is always with respect to dx. Minus 17 integration of x, and 6 is there, so integration 6 I am taking outside, it will be dx, integration of dx, and integration of dx is simply x. See, there is no integration of dx, actually it's integration of x to the power 0. Anything with which has power 0, it is 1. So we don't have anything with dx, so we call it as 1 into dx. That's why we write 1 as x to the power 0. Then we can apply the formula of integration. So we get 12, x cube is x raised 4 by 4, this is x 3 by 3 minus 17. This will be x square by 2. Then we have 6. This is x to the power 0 plus 1, that is x. Actually, always remember the integration of dx will always be x. So just one cancellation, other terms remains the same, that is minus 17 by 2x square plus 6x, only 12 and 4 we have cancelled out. All other terms with a constant of integration. This is your final result. So this is how it will be done, final result. Now this question, one by one we need to deal with them. So integration of m by x plus dx will always be there. Integration of x by m dx. Integration of m raise x, integration of x raise m, and then we have integration of mx dx. So we will take the constant outside and deal with the variable with dx. So m I have taken constant, it will be dx by x. Simply 1 by x different integration will do. This 1 by m will come outside, x dx integration. This is m raise x dx, This is x to the power m dx. We can directly apply the formula here. And this is mx. M I am taking outside. It is simply x dx. So let us deal with them one by one. Integration of 1 by x is simply ln x, log x. ln is simply log with base e. And always we write in in modulus. Modulus. Always positive sign. We cannot have a negative sign. So ln modulus x is log base e modulus x. That is the absolute value of x. Integration of x is x square by 2. Because integration of x is n x raised n plus 1 by n plus 1. So x square by 2. We have x square by 2 m. 1 by m was already there. M raised x. A raised x integration is a raised x divided by log a. Base is e. You can simply write it as ln also. So this m raised x log e base. So ln m. Then we have x raised m. X raised m is simply x raised m plus 1 by m plus 1 plus m. Integration of x, we just did it. It will be x square by 2. And then the constant of integration. This is your final result. So this is the whole thing which you completed just now. Next one is, it seems at first sight, oh, how to do this? But if you know this a minus b whole square, which is a square plus b square minus 2ab, now this under root x, under 1 by under root x is a and b. So I'm applying the formula here, that is under root x minus 1 by under root x whole square. A is under root x and b is 1 by under root x. So just square them. And a square plus b square minus 2ab, minus 2 into under root x into 1 by under root x. So this square is, under root x square is what? When you square it, x, it's simply under root x is x to the power half. When you square it, it will be multiplied. 2 into half is same thing. So you have 1 by under root here. 1 by under root is 1 by x to the power half. When you square it, again, half into 2, you can multiply. So it will be simply 1 by x. And this under root x and 1 by under root x will get cancelled. So x plus 1 by x minus 2. So what do you get here? Integration of x dx plus integration of 1 by x dx, then minus 2 integration of dx. So integration of x to the power n, as we have been discussing a lot now, x to the power n plus 1 by n plus 1. No integration sign please, there is a slight thing which you need to change. Once you write the formula result, no integration sign then. So integration of x is x square by 2, 1 by x is ln x log base c modulus of x minus 2 integration of dx is simply x, and then the constant of integration capital C. This is your final result. So this is what we have done. It's quite easy now. Okay, this question we'll be taking in the next discussion. Till then, thank you so much and take care of yourself.